In the depths of the Pacific Ocean, a discovery changed everything: a thriving community of life at hydrothermal vents, teeming with organisms that defy imagination. These vents spew superheated water at temperatures exceeding 400 degrees Celsius, creating oases in an otherwise barren abyss, where the crushing weight of water presses down at over 250 times the atmospheric pressure at sea level. Life here does not depend on sunlight. Instead, it thrives through chemosynthesis, using chemicals from the vents, like hydrogen sulfide, for energy. Tube worms rise over 3 meters long, their vibrant red plumes waving in the hot water, reliant on symbiotic bacteria that convert toxic chemicals into food. This alien landscape is home to giant clams, deep-sea shrimp, and bioluminescent creatures illuminating the darkness in mesmerizing displays. The biodiversity at hydrothermal vents reveals complex interactions within these ecosystems. Each species plays a specific role, creating interdependent relationships that sustain the entire community. Certain mussels, for example, provide habitat and nourishment for microorganisms, showcasing an intricate web of life that challenges our understanding of ecological dynamics. Why do these adaptations matter? Scientists are uncovering clues about the origins of life on Earth. The discovery of extremophiles, organisms thriving in extreme temperatures and pressures, may offer insights into potential life beyond our planet. Astrobiologists find parallels between these environments and icy moons like Europa and Enceladus, which may harbor unknown life forms. This connection between extreme adaptability and the search for extraterrestrial life holds potential for groundbreaking advances in biotechnology. Researchers investigate unique enzymes and compounds produced by these organisms for applications in medicine and renewable energy. What happens next could change everything as we unlock the secrets held within these mysterious ecosystems. The need for ocean conservation is urgent. Human activities like deep-sea mining and climate change threaten fragile ecosystems that have existed for thousands of years. Protecting hydrothermal vents is crucial for understanding our planet's health and resilience. The stakes are high. Without action, we risk erasing these discoveries and their potential benefits before we understand them. With over 80% of our ocean still unexplored, what incredible discoveries await us in the dark? The secrets of the ocean beckon us, urging respect and curiosity. The journey into the unknown is just beginning, and the revelations awaiting us may reshape our understanding of life on Earth and beyond. As we plunge deeper, life burgeons against all odds. Hydrothermal vents erupt from the ocean floor, casting plumes of mineral-rich water into the frigid depths. These surreal oases, stark against the barren landscape, demonstrate nature's resilience. The extreme temperatures create an alien environment dominated by unique adaptations. Among the most remarkable inhabitants are tube worms, with vibrant crimson plumes resembling fantastical bouquets. In the absence of sunlight, they rely on chemosynthesis, converting chemicals from the vent into energy through symbiotic bacteria. These bacteria transform sulfur and methane into life-sustaining energy for the worms and other species. Each plume of the tube worm breathes life into the darkness, almost as if the ocean itself were painting in bold strokes of vivid red. Giant clams, balancing precariously on the rocky substrate, have shells as large as a dining table. Their iridescent mantles ripple with color, an ethereal display against harsh surroundings. They harbor life within, a network of bacteria weaving existence in darkness. This cohabitation allows them to thrive in an otherwise inhospitable environment, illustrating nature's ingenious ability to find synergy where others see only desolation. Research reveals these creatures possess genes allowing them to thrive in lethal environments. Their genetic blueprints could unlock new understanding of resilience and adaptation. Dr. Jody Smith, a marine biologist, once stated, "The more we learn about these species, the more we begin to see the blueprint of life itself." Her research highlights that these astonishing adaptations do not merely exist as curiosities, they represent living laboratories from which we can extract vital knowledge about surviving the extremes. Bioluminescent species, such as stunning deep-sea jellyfish, pulse with surreal glows, illuminating inky waters. Their light attracts prey and deters predators, a delicate reminder of life's resilience. This mesmerizing display serves a dual purpose, drawing in unsuspecting fishes while also serving as a warning to would-be attackers. Exploration unveils an intricate web of life, with species like unusual fish navigating the hot waters. Each plays a vital role in this harsh ecosystem, relying on one another for survival. Recent research reveals the significance of these ecosystems in global carbon cycles, showing their role in mitigating climate change. Scientists are discovering that some of these organisms can capture and sequester carbon, a process crucial in regulating the Earth's climate. As we learn more of their roles, we uncover ancient stories written in the language of the ocean, maps of interaction and interdependence that stretch back millions of years. Yet, we must tread carefully. These unique ecosystems face threats from human activities. Recent studies show minor disturbances can have cascading effects, emphasizing the urgent need for conservation efforts. A mere shift in temperature or chemical composition from deep-sea mining can lead to irreparable damage, decimating entire communities. The fragility of these ecosystems underscores the responsibility that comes with discovery. The more we learn, the more imperative it becomes to protect these wonders. As we unravel the mysteries of these underwater realms, we are reminded of the interconnectedness of all life. The vents, vibrant with forms and untold stories, challenge our perceptions of survival. Each discovery fuels our curiosity, urging us to seek deeper truths about life on our planet. The hydrothermal vents beckon us to protect the wonders of our blue planet for generations to come. In the profound darkness of the deep sea, a remarkable world unfolds, where harsh conditions foster extraordinary forms of life. Hydrothermal vents release plumes of mineral-rich water, creating biodiversity against an abyssal desert. These vents, located along mid-ocean ridges, nurture a vibrant ecosystem, challenging our notions of survival. The historical significance of hydrothermal vents cannot be overstated. They were first discovered in 1977 during the submersible Alvin's expedition to the Galapagos Rift. Before this monumental discovery, the prevailing belief held that life could only exist in environments illuminated by the sun. Yet, on that fateful dive, the first glimpses of life at these vents shattered our understanding of biology. What researchers found were not mere traces of life, but thriving communities, with tube worms and clams basking in what could only be described as the Earth's hidden gardens, lush with life, yet shrouded in darkness. Among the iconic inhabitants are giant tube worms, thriving without sunlight, relying on symbiotic bacteria converting toxic compounds into energy. This relationship raises profound questions about the origins of life on Earth and beyond. If life can thrive in extreme environments, could similar forms exist on distant celestial bodies? Dr. Mia Chen, an astrobiologist whose work focuses on extreme environments, emphasizes, studying hydrothermal vents teaches us that life is not just limited to the conditions we know, it expands our horizons towards the cosmos. On icy moons, where the oceans are hidden beneath layers of frozen crust, the chemical exchanges at hydrothermal vents present tantalizing possibilities of life. Astrobiologists speculate that just as life flourishes in the extreme temperatures of Earth's depths, the same could be true in the frigid waters beneath Europa's icy surface, where hydrothermal activity might mirror Earth's ancient past. The implications stretch beyond curiosity, they redefine existence. Astrobiologists speculate about life on other planets, and the existence of extremophiles offers critical insights. What once seemed improbable now falls within possibility, inviting re-evaluation of the conditions necessary for life. In the 1990s, the concept of life elsewhere relied heavily on our understanding of life on Earth. Yet as we watched these remarkable adaptations unfold in the darkness of our own oceans, entire new fields of thought and inquiry arose, pushing boundaries into the stars. The proteins from extremophiles exhibit incredible stability, making them invaluable for scientific research. Enzymes derived from these organisms withstand extreme conditions, serving as tools for advancements in biotechnology. The vast potential of applications burgeons, shifting discussions towards sustainable practices and innovative solutions. As we stand on the edge of discovery, the exploration of these ecosystems might rewrite biology and address humanity's greatest challenges. The urgent need for new treatments for diseases, sustainable energy sources, and methods for climate change mitigation intertwine with the discoveries made in the depths of our oceans. This excitement must be tempered with urgency. Human actions threaten the delicate balance of hydrothermal ecosystems. Understanding the interconnectedness of life and our environment is crucial. The mysteries of hydrothermal vents invite reflection on the essence of life itself and the need to preserve potential benefits. Each moment spent studying these ecosystems is shadowed by the reality of human impact, reminding us that our discoveries come with precious responsibility. Our understanding teaches us about resilience, adaptation, and interdependence. Yet, climate change and pollution loom ominously over these habitats. Each plume of hot water carries the weight of our actions, reverberating through marine life. The delicate balance maintained by these ecosystems serves as a reminder that every action creates a ripple effect throughout the environment, echoing into the future. With every intact vent, we ensure the survival of not just individual species but the entire community of life that depends upon it. In the face of this challenge, conservation becomes imperative. Efforts must preserve the physical structures of hydrothermal vents and foster respect for the systems that sustain them. Safeguarding these ecosystems protects the legacies of life they represent, an intricate tapestry of connection within our planet's narrative. As we uncover the living history of these vents, we are called to protect what remains, to act as custodians of these alien worlds. Each effort in conservation is an investment in understanding, not just of the past but of the future, recognizing that the choices we make today shape the world of tomorrow. As we continue this exploration, let us carry the message of these incredible organisms. They remind us of life's adaptability and the beauty of the natural world. With each dive, we edge closer to understanding not just the depths but also our responsibility to be stewards of our planet, recognizing our fate intertwined with that of the ocean. The mysteries of hydrothermal vents compel us to reflect on the essence of life and the need to preserve knowledge and potential for a vibrant future. In this age of discovery, respect for the ocean's ecosystems is essential. The triumphs of life in extreme conditions teach us resilience and hope. As we draw closer to the shore, we realize the ocean's depths hold not just adaptations but life secrets transcending our understanding. The vibrant communities of extremophiles serve as witnesses to our past and testimonies to our future, beckoning us to delve deeper into existence while imploring us to act with urgency. The ocean's last frontier waits, shimmering with promise, a realm of wonder that, if protected, may unveil infinite possibilities in the great tapestry of life on Earth.